Hello everyone. In this video, I'm going to run through a technique you can use to create rich textures for large terrains. This technique uses automatic tiling techniques and masks, so you can make what seems to be huge open spaces while using just a small number of not very big textures. This video isn't going to get into mega textures though, which is a completely different technique. That's something I might come back to in a future video. Anyhow, we're going to start in Blender, where I will show you how to create a tiled and layered texture shader for terrain meshes. Then we'll jump into Godot, where I will show you how to use a shader library I've developed that creates a very similar effect. Our first stop is to Polyhaven to download some textures to use in our scene. We're going to be using normal and roughness maps in our terrain, so we'll make sure we get textures that have those. I'm going to be using the smallest 1K textures, but you can use larger ones if you want more detail. We'll also grab an HDRI that we can use for background lighting. Okay, let's open up Blender. I've already created a mesh that we'll be using as a base. You can make sure its UVs are laid out properly by hopping over into the UV editor, pressing numpad 7 to go into top view, and then pressing U for the unwrap menu, and picking Project from View, Bounds. Of course, you can set up the UVs however you want if you need them to be something different. We'll also rename the default material on our mesh to Terrain Material. Now let's open a viewport for the shader window. Let's start by throwing on a quick HDRI for some lighting. And switch to viewport shading mode. Switch back to the object section and we can get to work on our shader. To start with, we'll hook up the diffuse, roughness, and normal maps the way we usually do. We'll also press Ctrl-T to automatically add the UV mapping nodes. Make sure that you have the node wrangler installed and enabled, or this step won't work. Hook up the output of the mapping node into the other texture nodes too, so that they have the same UV transformation. Now set the UV scale to 40 and the texture will be shrunk down to the right size. Now we have the texture covering our terrain at about the right density, but it looks pretty bad. That regular tiling pattern is pretty unnatural. Luckily, there is something we can do about this. If we think of each one of those tiled patches as being in its own square, we can shift them around so that they all seem jumbled up. That way we can make that small texture map look huge just by rotating and translating little bits of it. Instead of splitting the mesh itself into lots of tiny pieces, we can make it look the same way using a shader trick. We're going to get this shifting effect by messing around with the UV coordinates of our nodes. Let's start by adding a new mapping node to our network and slide it in just after the mapping node that's already there. Now click on it and press Ctrl-G to turn it into a group. We're going to turn this group into our tile shuffling tool, but first we need to fix how it's connected to the rest of our network. Go back out to the outer network by pressing Ctrl-Tab, and let's update the connections so that the output of our group is sent to the inputs of all our other textures in our shader. This way, any changes we make inside our new group will affect all of the texture maps. Now select the group node again and press Tab to dive back into it. Normally, when you use UVs, you only need to pay attention to the fractional part. This is because texture maps repeat for every multiple of 1, and so the integer part doesn't affect how it is displayed. However, we can take advantage of the integer part to uniquely identify each cell. For this reason, we're going to be using a floor node that just leaves us with the integer part of a UV coordinate. We can then feed this coordinate into a white noise texture which returns 3 random values for that cell. We can then use those random values to create a unique translation and rotation vector for the cell that we can then feed into our mapping node. When it's all set up, every UV within the cell will have the same random mapping applied to it. To get a better idea of what's going on, you can try looking at a texture that has obvious edges. Here you can clearly see where the tiles meet. This is already looking a lot better, but you likely want to have a landscape with more than just one type of texture on it. This is where masks can come into play. We can repeat what we did with the base texture, but with other textures, and then use masks to blend them together. Let's start by cleaning things up a bit. Select the diffuse, rough, and normal maps, and then press Ctrl-G to put them all into the same group. This is mostly for neatness, because we're going to be adding a lot of texture nodes to our graph. Next, we'll make a copy of it by pressing Ctrl-D, and then press the number 2 button in the middle of the texture node to make it unique. If you don't do this, any changes you make inside this new node will also affect the original texture group. Press Tab to enter into it. Since it's now unique, we can replace the textures here with textures for another material. Now go back to the outer graph and create a new texture node. Click the button to create a new texture and name it Mask Forest Ground. We will be using a color channel from this to mix between the two layers. Create 3 mixed color nodes and use them to blend between the different texture layers. We do this by connecting the layer that is going to be on the bottom to the A slot, the layer that is going to be on the top to the B slot, and the mask itself to the factor slot. Once this is done, Select the 3 mixed nodes and press Ctrl G to group them. You can now change to texture paint mode to start painting your mask. Make sure you have the mask texture you want to paint into selected, otherwise you will paint into the wrong texture. Also, make sure the viewport is displaying in rendered mode so that you can see the effects of your painting. Now you can paint artistically to create a blending mask between your 2 layers. Now that you have this basic setup worked out, you can easily add an extra layer by repeating this whole process. Duplicate the texture group and make it unique. Duplicate the mask blend group, create a new mask texture, and hook it all up. You can add as many layers as you like in this fashion and build up your terrain. Make sure to pack your mask textures or save them to disk, or they will be lost when you close Blender. And here's the network with yet another layer added. We're nearly done with Blender. We're almost ready to export, but now we have several different mask textures which only represent one channel of black and white data. Since each image holds 4 data channels, it seems wasteful to use an entire image just for a single channel. Isn't there something we can do about this? Turns out there is. Click on the Compositor tab. Normally this tab is used to add post-processing effects to your render, but we can also use it to combine our masks into a single texture. Press Shift A and create a new image node. Choose one of your masks from the drop-down. Now create a Combine Color node. Feed the outputs of the color of each mask to one of the inputs of Combine Color. Now do it again and create new image nodes for each one of your mask textures. Finally, create a File Output node and send the image output of the Combine Color node to it. Set the file name to the path where you want the combined image to be written. If you have more than 4 masks to output, you can repeat this process by creating an extra Combine Color and saving it to a different File Output node. Finally, to actually generate the image, you have to run the renderer by pressing F12. When it's done, the combined masks will be saved to disk, and you'll have a rendering of your scene too. Finally, we can export our mesh for our game engine by using the GLTF exporter. This won't save any of our node network, but that's okay. We'll be writing a new one on the game engine side. Now, let's create a new Godot project where we're going to texture our terrain. First, create a new scene and bring in the terrain mesh that we exported from our 3D program. Don't worry about any material that is currently on it. We're going to be replacing that. Next, you need to have the Terrain Layered Shader add-on in your project. You can download it from its GitHub page or get it from the Godot asset library. In either case, just make sure all the code is in the add-ons directory. Just copy and paste it into your project inside of the Add-ons Terrain Layered Shader folder, and it should work. Select the mesh, and in the scene window, right-click the mesh and select Editable Children. This will give us access to the inner nodes so we can change the material. Select the grid mesh and open Surface Material Override area in the Inspector panel. Click on the first slot, and now you can create a new material for your shader. Click on Shader Material, and then drag the Terrain Shader Base.tres from the project into the shader parameter. This will set up the shader for you. You now need to adjust these so that they match the base layer of your terrain. Just copy the values that you used in your Blender shader, and they will match the values used by this shader. You can also adjust the tile margin, which will affect how much the tiles blend into their neighbors. We'll leave it at 0.1 since this looks good with this texture. Now you can start adding the next layers to your shader. We're going to do this one layer at a time. To add your next layer, select the Next Pass field and create a new shader material there. Now drag in the Terrain Shader Mask.tres file. The shader is similar to the base layer shader, but has some important differences. First, the mask shader is partially transparent, while the base layer is opaque. This lets the mask shader sit on top of the shaders below it, but can cause rendering artifacts if the base layer is not opaque. Always make sure to start with the base shader and then add mask shaders on top of it. And of course, the mask shader has a mask while the base shader does not. Now that we've added a mask shader, we will need to set up the mask. Open up the mask section and add up the mask texture to the texture mask slot. You now need to tell the shader which of the channels to use. Remember that to save space, we pack several different masks into a single texture on different channels. Well, here we use the mask channel to tell the shader which channel to use. So, if the mask we want is packed into the red channel, turn the red slider up to 1 and leave the others at 0. We can also adjust the mask scale parameter to give a boost to the mask if it is not dark enough. Now you can repeat this process to add as many layers as you want. Just add a new shader material to the next pass slot of the top shader, drag the Terrain Shader Mask TRES into its shader field, and set up its parameters. At this point, your terrain shader will be good to go, but if you want to dig into the details a little more, you can open up the shader code by clicking on the shader editor in the bottom panel. The terrain base and mask shaders both started out as shader code generated by Godot from the standard Material 3D. I cleaned it up a little and made some changes to the render flags and parameters. The big change I then made was creating a new sample tiling method that replaces the typical texture lookup function. This function was defined in terraintools.gdshader and performs fancy calculation based on the UV values to come up with the shuffled tile effect. It's basically doing the same math we did to the UVs in the Blender shader, but with a twist. Instead of just calculating the adjusted UVs for one cell, it also looks up the UVs for the 3 nearest cells as well. It then samples the colors from these 4 sites and blends them together based on the width of the margin parameter. This is something we couldn't do in the Blender shader due to restrictions in Blender Shader Network. One final thing to mention is the random.gdshader file. Recall that in the Blender shader we had the white noise texture that we were used as a source of randomness. While GLSL does define a random function, Most shader manufacturers do not actually implement it, so you cannot rely on it actually working. As a result, we have to supply our own pseudo-random number generator if we want to reliably generate random numbers on all platforms. This code was written by Spatial and slightly modified to work in Godot to provide us with good quality pseudo-random number generation. So, that is how you can paint a custom terrain object in Blender and recreate it using layers and masks in Godot. These shaders should also work with other kinds of meshes where you want to build up a scrambled tile effect in layers. By using layers this way, you can allow for lots of detailed tweaking of each individual layer, as well as features like normal and roughness maps. This add-on will be available from the Godot asset library and can also be downloaded from its GitHub page. Links will be in the description below. Anyhow, I hope you found this tutorial useful, and good luck with your terrain projects.